Welcome to our series in which we are discussing very important test questions. These questions are asked in many competitive exams also. Have a look at this one, which relates area of triangle with inscribed circle. I hope you find it interesting. In case you want to learn from me, you can always send an email on the address given. Let us enjoy the journey of learning with success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up thinking application question, which will help you to practice for competitive exam. This kind of question can be asked at any level, maybe Olympiad, SAT, or any other competitive exam. It is based on area of right triangles. I would like you to pause the video, read the question, answer, and then look into my suggestions. The question here is, circle is inscribed in the right triangle as shown. The circle touches the hypotenuse, divides it in the lengths x and y. Show that the area of the triangle is x times y. So here you see the circle inscribed within a right triangle ABC, and the point which touches the hypotenuse divides it in the ratio x and y. We need to find the area of triangle, and it is as simple as product of x and y. It is important to know this, and also we shall make an attempt to show that that is indeed the case. How can you solve such a question? So let's do a bit of thinking about it. How can we relate different things? Well, it is a right angle triangle, so we know that AB square plus BC square is indeed equal to AC square. So that is Pythagorean theorem. And AC square can be written as sum of x and y whole square. So that is one kind of relation. As far as the area is concerned, we know what area of triangle is. So area of triangle ABC can be written as half of base, which is BC, times height. Let me write product. Okay. Times height, which is AB, since the triangle given to us is a right angle triangle. So we have base and height. Perfect. How do we relate AB, BC with x and y? That is the critical part. Now if you look at it, from an external point A, the length of tangents should be same, and that is what helps us to simplify and find the solution. So it really means that if the circle is tangent to the three sides, let's say they are at P, Q, and R, in that case, the length A to R should also be x, right? So this is also x. And the length C to P is y. So from here, we see that the length AR is equal to x, since that should be equal to AQ. And the length C to Q, which is CP, is equal to y, which is same as C to Q. Because we have length of tangent from an external point to the circle. correct? From a point. So that is another theorem which actually helps to find this relation. Now that's not difficult to prove if you don't know about it. Very simple. So anyway, let's take this as the center, and now we can say the circle, right? So if the circle is of radius a, let us say, or let's say small r, then from this particular diagram, you can figure out that a to b should be equal to what? A to b will be x plus r, because this side is equal to r, right? And b to c is y plus r. You get the idea. So now all of a sudden, we got AB, BC and AC all in terms of x, and also the radius of the circle inscribed in this particular triangle. Perfect. So that is a great hint, and I think that should help you to solve the question, correct? And therefore, we can say that the area of this particular triangle is basically equal to half of x plus r times y plus r. And then do some algebra and get the result. Is that clear? So I think with this hint, you should continue and find that the area of this particular triangle, right angle triangle, should be xy, where x and y is as shown in the figure. Perfect. So with that in mind, let's now try to do it. So what we just talked about is that this circle with the radius small r and the tangent's length being equal from external point, we have this length as x, the other one y, and this is y plus r, correct? So that is how the area is. So we can write that the area is basically equal to half of x plus r times y plus r. So if I expand this, what do I get? I get half of xy plus xr plus yr plus r square. And that gives you half of, let's put this in brackets, right? It should be. So we have xy plus x is common, or rather, x, we could write x plus y with r common plus r square. Now we need to show that this is kind of xy. How do we do that? And for that, we learn that the squares of the two sides is same as the hypotenuse square. So let's do that part, which is x plus r whole square plus y plus r whole square should be equal to x plus y whole square. And let us see what do we get out of this. So if you expand, we get x square plus 2rx plus r square plus y square plus 2ry plus r square is equal to x square plus 2xy plus y square, correct? Now we can simplify this by cancelling the terms, which can be cancelled. 2 times r x plus y plus 2r square, right, is equal to 2xy, right? This is what we get, correct? Yeah, this is 2rx, not 2yx. We can cancel the 2's. So we get r times x plus y plus r square is equal to xy, right? So now we got an expression equivalent to r times x plus y plus r square, and that is xy. Substituting that, we get what? We get half of xy plus xy. Is that clear to you? Right? So let's call this as equation 1, this as equation 2, and we sub 2 in 1. Does it make sense? And clearly, this is 2xy, and divide by 2 will give us what? Xy. And that is how we show that the area of this right triangle is indeed xy. Perfect. So I hope it makes sense. Very beautiful question. And a proof which involves a lot of algebra. Depending on at which level you are, it could be a very difficult example to work with. Many times it is a bonus question in some middle school or grade 9 test papers. So I hope that makes sense. In case you want to learn from me, you can always send an email on the address given.